वेलकम टू B2 नेट कोड चैनल। गाइस, आज के सेशन में हम देखने जा रहे हैं स्पैनिंग ट्री प्रोटोकॉल। So first of all, let me make sure that spanning tree protocol and twisted pair, these two are different terms, right? So let's not confuse them. Spanning tree protocol is a algorithm, whereas shielded twisted pair, it is a cabling mechanism of cables. Let's see what is spanning tree protocol. Ethernet bridges and switches can implement the IEEE 802.1d spanning tree protocol and use the spanning tree algorithm to construct a loop-free shortest path network. Shortest path is based on cumulative link costs. Link costs are based on the speed of the link. तो गाइस, हम रिडंडेंसी पर्पस के लिए लिंक के मल्टीपल कनेक्शंस बनाते हैं दूसरे स्विचेस के साथ। तो दैट creates the possibility of loops, right? So for that, spanning tree protocol was designed, and so that we can have a loop free network. So spanning tree protocol, it provides us a loop free redundant network technology by placing certain ports in the blocking state. तो इसमें हमें ये भी मेंशन कर रखा है what will be the cost of the link speed as per IEEE. So if we have 10 Gbps connection, the this is the revised cost, right? जो हमारी previous specification थी वो ये थी, that is towards right hand side 1. But today we consider 10 Gbps connection as cost 2. For 1 Gbps we have cost as 4, 100 has 19, and 10 Mbps has 100. Let's go to next slide. A spanning tree protocol establishes a root node called the root bridge or root switch. The spanning tree protocol constructs a topology that has one path for reaching every network node. The resulting tree originates from the root bridge or switch. The spanning tree protocol requires network devices to exchange messages to detect bridging loops. Links that will cause a loop are put in blocking state. The message that a switch sends allowing the formation of loop-free logical topology is called as bridge protocol data unit. Right, just as in OSI model, we see the PDUs. Similarly, in case of switches, in case of spanning tree protocol, we call those data units as bridge protocol data units, BPDUs. So we have one root BID, root bridge. Then the path to reach that root bridge is called a root path, and the cost is the how far away is the root bridge. That determines how many what kind of network or how many switches one has to cross to reach that root bridge. Sender BID, it is the what is the BID of bridge that sent this BPDU is called the sender BID. And port ID, what port on the sending bridge does the BPDU come from? So ये थोड़ी terms है, हमें याद रखनी पड़ेंगी. Now let's have a look at the overview. Redundancy in a network is extremely important because redundancy allows network to be fault tolerant. Redundant topologies based on switches and bridges are susceptible to broadcast storms, multiple frames transmission, and MAC address database instability. Therefore, network redundancy requires careful planning and monitoring to function properly. The spanning tree protocol is used in switched networks to create a loop-free logical topology from a physical topology that has loops. Guys, even if one frame is broadcasted and is creates a loop in a network, right? It can eat away all your bandwidth. So that's why our network should be loop-free. No frame should revolve in network forever. So that's why we need something to control the frames, broadcasts, storms, or loops. So network with the redundant paths at devices allow for more network uptime. In the graphic, let's see what is the graphic. If switch A fails, okay, uh, traffic can still flow from segment 2 to segment 1, because we have two switches that are connecting segment 2 and segment 1. If one switch fails, then we have a redundant path to reach to segment 1. So this is called redundancy. If port 1 fails on switch A, then traffic can still flow through port 1 on switch B. Switches learn the MAC addresses of devices on their ports so that data can be properly forwarded to the destination. Switches will flood frames for unknown destinations until they learn the MAC address of the devices. A redundant switched technology topology may cause broadcast storms, multiple frame copies and MAC address tables instability problems. अगर ये आपको समझ नहीं आए तो हम और डिटेल में चलते हैं इसको. What are broadcast storms? Broadcast and multicast can cause problems in switched network. Multicast are treated as broadcast by switches. Broadcast and multicast frames are flooded out all ports except the one on which the frame was received. The switches continue to propagate broadcast traffic over and over. This is called as a broadcast storm. This will continue until one of the switches is disconnected. The network will appear to be down or extremely slow. So this is the reason why we don't have to allow broadcast storms to happen in our network, because they will kill our entire bandwidth. Let's see what is multiple frame transmission. In a redundant switched network, it is possible for an end device to receive multiple frames, right? As you can see in the picture below, a frame can be received by any device from multiple locations, because every location, every device is connected to two more devices. So this can produce instability in the network. Assume that the MAC address of router Y, here is the router Y, has been timed out by both the switches. Also assume that host X still has the MAC address of router Y in its ARP cache and sends a unicast frame to router Y. Switch A doesn't have the MAC address of router Y and will therefore flood the frame out its ports. Switch B also doesn't know about which port router Y is on. Switch B then floods the frame it received, causing router Y to receive multiple copies of same frame. This is cause of unnecessary processing in all devices. And now let's see what is MAC database instability. A switch can incorrectly learn that a MAC address is on one port when it is actually on different port. In this example, the MAC address of router Y is not in MAC address table of either switch. Host X sends a frame directed to router Y. Switches A and B learn the MAC address of host X on port 0. Right, we are taking this example. The frame to router Y is flooded on port 1 of both switches. Switches A and B see this information of port 1 and incorrectly learns the MAC address of host X on port 1. When router Y sends a frame to host X, switch A and B will also receive the frame and will send it out port 1. This is unnecessary, but the switches have incorrectly learned that host X is on port 1. So this causes MAC database instability, because one MAC address is coming from two different sites, two different ports. So this was the reason STP was invented. Now see, what is how do we select the root bridge? The first decision that all switches in the network make is to identify the root bridge. The position of root bridge in a network will affect the traffic flow. When a switch is turned on, the spanning tree algorithm is used to identify the root bridge. BPDUs are sent out with the bridge ID. Right. The bridge ID consists of a bridge priority that defaults to 32768 and the switch base MAC address. Guys, अगर आपने मेरे पीछे practical videos देखे हैं, so you must know that what is bridge ID and what is the default ID of a bridge. Okay, that is 32768. When a switch first starts up, it assumes it is a root switch and sends BPDUs. These BPDUs contain the switch MAC address in both the root and sender BID. As a switch receives a BPDU with the lower root BID, it replaces that in the BPDUs that are sent out. All bridges see these and decide that the bridge with the smallest BID value will be the root bridge. A network administrator may want to influence the decision by setting the switch priority to a smaller value than the default. Let's see what are BPDUs. BPDUs contain enough information so that all switches can do the following. Select a single switch that will act as the root of the spanning tree. Calculate the shortest path from itself to the root switch. I mean root bridge, right? Designate one of the switches as the closest one to the root for each segment. This bridge is called the designated switch. The designated switch handles all the communication from that LAN towards the root bridge. Each non-root switch choose one of its ports as its root port. This is the interface that gives the best path to the root switch. So guys, मैंने आपको बताया था कि हर एक ब्रिज का के पोर्ट के सामने वाला पोर्ट होगा रूट पोर्ट और ब्रिज का हर एक रूट ब्रिज का हर एक पोर्ट होगा designated पोर्ट, right? Select ports that are part of a spanning tree. The designated ports, non-designated ports are blocked. Right? हम लूप को कैसे कंट्रोल करते हैं बनने से? By putting non-designated ports into blocking mode. चलिए स्पैनिंग ट्री ऑपरेशन देख लेते हैं. When the network has stabilized, it has converged, and there is one spanning tree per network. As a result, for every switched network, the following elements exists: one root bridge per network, one root port per non-root bridge, one designated port per segment, unused non-designated ports. Root ports and designated ports are used for forwarding data traffic. Non-designated ports discard data traffic. Non-designated ports are also called blocking or discarding ports. Right guys, ये अभी रूट ब्रिज की तरफ जाने के लिए हमारे पास दो पाथ हैं मान लीजिए तो सी से राइट. तो ये एक पाथ हमने ब्लॉक कर दिया तो नाउ देयर इज ओनली one path to reach the root bridge. As a result, loop will not be created. So for this cat B switch, category B switch, right? It has one path to reach to root bridge. Other path is blocked, right? So now in this network there is no multiple paths to reach to root bridge. As a result, this network is converged. तो ये पोर्ट स्टेट्स देख लेते हैं कौन कौन सी पोर्ट्स होंगी. First of all, a port will be in blocking state. The port is an alternate port and does not participate in frame forwarding, right? The port receives BPDU frames to determine the location and route ID of the root bridge switch and which port roles each switch port should assume in the final active STP topology, right? Guys, जो पोर्ट ब्लॉकिंग स्टेज में होगा वो BPDU रिसीव करेगा but it will never send the BPDU. And listening state listens for the path to the root. STP has determined that port can participate in frame forwarding according to the BPDU frames that the switch has received. The switch port receives BPDU frames, transmits its own BPDU frames, and informs adjacent switches that the switch port is preparing to participate in active topology. Learning state learns the MAC address. If switch is in learning state, then it learns the MAC addresses and prepares to participate in frame forwarding and begins to populate the MAC address table. When the switch is in forwarding state, now switch is considered as a part of active topology, and it can forward data frames and send and receive BPDU frames. And there is one more state that is called disabled state. The layer 2 port does not participate in spanning tree and does not forward frame. The disabled set is when the switch port is administrative disabled. In case we have a given shutdown command for any port, that will port will never participate in spanning tree election, right? It will never learn anything from that port. Let's go to next slide. तो ये हमने पोर्ट्स अभी डिस्कस करी तो वो देखते हैं कैसे चलता है. फर्स्ट ऑफ ऑल लिंक comes up, then it moves from blocking to listening state after it decide it is a root port or a designated port. Then if it goes to blocking, if loss of BPDU detected, that is for 20 seconds, no loss of BPDU is detected. In case the BPDU is detected, then it will go to listening stage. That happens for the 15 second, and after listening, a switch moves to learning stage. That is again 15 second. After that, we have the forwarding stage. Now switch port goes into forwarding, and from where it can uh, send and receive BPDUs. So every port of the switch go through these stages whenever it is shut down or the powered on. Let's see how spanning tree does the recalculation. A switch network has converged when all the switch and bridge ports are in either the forwarding or blocked state. Forwarding ports send and receive data traffic and BPDUs. Blocked ports will only receive BPDUs. The reason why block ports receive BPDUs because only then it will come up if it will receive BPDUs, right? So in case of port any port failure or switch failure, when the network topology changes, switches and bridges recompute the spanning tree and cause a disruption of user traffic. Convergence on a new spanning tree topology using IEEE 802.1d standard can take up to 50 seconds. तो ये 50 seconds कैसे calculate होते हैं guys, हमने अभी देखा 20 seconds blocking के लिए और उसके बाद 15 seconds listening and 15 learning के लिए. तो ये 50 seconds convergence में लग जाते हैं, right, in case any link goes down. So the convergence is made up of max age of 20 seconds. If for 20 seconds no BPDU is received, plus the listening forward delay of 50 seconds and the learning forward delay of 50 seconds. So guys, this way the bridging loops are controlled with the help of a spanning tree protocol. Uh, Logical loop free topology created with the STP. Right, so guys, this was our short presentation on spanning tree protocol. आपको ये वीडियो कैसा लगा आप कमेंट्स में बताएं, and if you like the video, if you learned something, if this video added to your knowledge, please like the video and subscribe to the channel for more videos like this. Thank you for watching this video.